Welcome to solverfy.
Okay, so for this one, we have a loop with a battery that's partially submerged in a magnetic field. So I'll denote the magnetic field with B. Blue, sorry, I have very synesthesia-ish, and B is luckily blue. So magnetic fields are always blue for me. Okay, so the magnetic field is out of the page. And we're told that this loop has sides of 2 point, how many zeros is that? Let's see, 00 meters. And we're told that B is equal to 0.0420 minus 0.870t. So the field is decreasing. And then the EMF is of the battery in the loop is 20.0 volts. And I think that's all we need. Okay, great. And so the questions asks, what is the EMF induced? Or excuse me, what do they ask first? What is the net EMF in the circuit? Okay, so there's already an EMF from the battery. And then, so I'm going to call that EMF BAT. And then there's an additional EMF because we're changing the flux. And so by Faraday's law, we're going to have a change in, or we're going to have a induced EMF. So can use our familiar formula. Hopefully you've used it a few times if you're at this problem. And so that's going to be the time derivative of the magnetic flux, which is BA, where A is the area intercepted by the flux, by the field. And so that area is constant, and it's just going to be L squared over 2 because only half of the square is in the magnetic field. And then we're left to just evaluate the derivative of B with respect to time. And so, yeah, so now we can say that dB dt is minus 0.870. I wrote that 8 backwards. Okay. So a negative constant. And so therefore this is, so we would plug this in here and then plug in L is 2 meters into here. And when I did this, I obtained that the EMF was 1.74 volts. And so on a comment on the signs, so we got a positive number, and that does actually indicate the direction that the current flows. But I think that the easiest way is to not learn the formalism of what the meaning of a negative and positive number is. Although if that appeals to you, of course, you can read about it. But I'm going to do it from the approach that I would use to think about this, because we have this EMF, and is this EMF going to go oppose the battery, or is it going to add to the battery? And you want to do this through kind of, I consider it a more narrative based approach. And so basically let's look at the physical situation. So we have this B field. The B field is decreasing in magnitude. And so the loop wants to induce a current to keep it the same. It's always a sort of restorative force. And so the B is going down. So we need this loop to try to make a B that goes up. And so, or out of the page, excuse me. And to do that, we would drive a current that's counterclockwise. And for a current to go counterclockwise, that corresponds to an EMF that's along the same direction as the battery, because the battery also would drive a counterclockwise current. So you can say EMF net is 21.74. I'm going to check one quick thing. Okay. And yeah, and so it's going to add to the current, to the EMF of the battery, and therefore cause a counterclockwise current. So maybe I'll kind of box these so that they're totally clear. So counterclockwise And then I get that for the net EMF because I added the battery to the EMF induced. Just gonna double check B is out of the page. Yeah, and then B is decreasing. Okay,